Welcome back to college algebra videos. This is our continuation of logarithmic functions. I want to recall a couple of things and then do one more example. So remember that our goal is to be able to graph logarithmic functions more efficiently. And in the last video we did is we looked at some properties, and there were two that I asked you to kind of recall very quickly. If the input of a log function is 1, doesn't matter what the base is, I don't care what the base is, as long as the input is 1, then the output will always be 0. I want you to remember that. And then if the input is the base itself, then the output is 1. And so these are the two things, I'm going to go ahead and box them up here. These are the two things that you want to sort of commit to memory. You want to highlight this and maybe memorize this and do some note cards, because this will become useful whenever you graph. In the last video, what we did with this example, and what the strategy that I use is I asked myself, okay, what makes this input 1? And so when I made my table, the reason I chose 0 as the input is because 0 plus 1 is 1. So that's where this input came from. And then I also asked myself, what makes this 3? And the reason I want 3 is because the base is 3. And so notice that if x is 2, 2 plus 1 is 3. And that's why these are the two inputs that I would consider sort of important for this particular graph. And so that's what would make it more efficient. I can plug these in, and then I know, using the properties from the previous slide, I know exactly what I'm going to get. So let's try this one more time with a base that we haven't seen yet, but one that I want you to be comfortable with. Okay, the natural log. So the natural log is just a fancy way to say the following. So this function really means this. So let me rewrite this. What we mean is that h of x is equal to log with the base of e, x minus 1 plus 2. Well, that sort of helps, because now it looks more like the other one, but at the same time, what is e? Well, e is a shorthand for a specific number that's very special to us, and you'll see why it's special when we start doing compound interest or exponential decay or exponential growth. But e is equal to 2.712, and actually let me use my calculator here because there's a lot more numbers to this. 2.712, oh sorry, 1828 1820, and so on and so on. It just goes on forever. It's a very special number that comes up in many applications. Kind of a very interesting number, to tell you the truth. But it's just a number. E is just a number, but we don't want to write 2.71828 blah, 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 blah. So we just say E. And so now I need to graph this. So I would like to make a table. So what kind of table do I make? Well, the usual. I want to know what makes this 1. And then I want to know what makes this E. That's really what I want. And so it takes a little bit of work here, but it isn't too hard. So the 1 part is easy. So h of x. Sorry. I think that what will make it 1 is 2. If you plug 2 into here, 2 minus 1 is 1, so that's good. And then the other input that I'm going to think, and this is where it takes a little bit of work, but the other one would be e plus 1. Okay, let me show you why this is true, why this would work, and why this is nice. So let me plug in, first of all, let me plug in 2. So h of 2 is equal to the natural log of, here's my input, 2, I should have put this in red, 2 minus 1 plus 2. But I know that that is just the natural log of 1 plus 2, and this just means log base e1 plus 2. But I've told you to memorize that when you plug in 1, no matter what the number is, you're going to get 0. So this is just 0, this part right here, this is just 0, so I just get 2. So this is equal to 2. So on my table, when the input is 2, the output is 2. Alright, not too bad. So let's try the next one. Let's plug in h, and let's plug in e plus 1. This will be my input. So this is the natural log of e plus 1 minus 1 plus 2. But notice here that this one and this one cancel out. So I'm left with the natural log of e, natural log of e plus 2. And hopefully now you're comfortable, but if not, I'm going to write it anyway. This is really log e base e plus 2. But I asked you to understand that when these two are the same, you're going to get 1. And so this is just 1 plus 2, which is equal to 3. So when I plug in e plus 1, I get 3. All right, so how do I graph this? Well, the point 2, 2 is easy. I go to the right 2 and up 2. So that's right there. And then e plus 1, that's a little interesting, right? But notice e is 2.7. So e plus 1 just means add 1 more. So e plus 1 is about 3.7. And so we estimate, we just want an idea of what this graph looks like. So I do go to 3, so my input here, this is like 3.7. And then my output is 3. So here is 4. And here is 3, so 3.7 somewhere in between, and then I have to go up 3. So my best guess is maybe right around here. Again, it's an estimate. The last thing is the asymptote. We know there's a vertical asymptote. And notice here's where the shift really helps. The shift 1 right. And so if I shift 1 right, the asymptote used to be at the y equals 0, x equals 0 line. So now the asymptote shifts here. And now once I have this asymptote, now I know that this graph, we know the shape of it. We know the shape looks sort of like this. And so we just do the best that we can. We know it goes towards the asymptote. We know this goes towards infinity. And then that would be a good graph. And most of the time when you're asked for this, they're usually multiple choice questions. So as long as you understand what the shape of the graph is, then you should be okay. I hope this helps with graphing. I hope this makes you faster. In the next video, we'll talk about domains. In the last 3 examples that we did, it'd be a good idea to maybe look at some domains.